Yes. Now look at this differential equation. Sine square x plus y into dy by dx is equal to, let's say, 1. I have a very simple question I'm doing. Now, whatever I do, I cannot bring all x term with the dx and all the y term with the dy. This is not possible. Whatever arrangement I do. I mean, do you agree with this statement, what I told you? I cannot
Yes.
bring all x with the dx and y with, so it is not a variable separable problem. Okay, but I can convert it into a variable separable method by substitution. You can see the angle of sine is not separatable. We said previously bad angle we said. Now I'm saying we cannot separate this. So the angle part is put as a new variable. Now how many variables are there total in this equation? X is there, Y is there, V is there. 3 variables are there. But a differential equation what we are solving has only 2 variables. That means I must remove one variable out of this. You know, x dy by dx, when I write, x is an independent variable and y is a dependent variable. So when I do the substitution, y should be removed, remove y and bring b in it. Bring this as a new variable. That means my new equation will contain only 2 variables, b and x. Did you understand that part? In substitution method of differential equation, one of the variable is removed. What is removed always? Dependent variable is removed. Dy by dx, y is the dependent variable. X is the independent variable. Now, if I want to remove this, what all things I should do? Wherever y is there, all y should go away. So, to get a duplicate for dy by dx, I'll differentiate this with respect to x, because x I'm going to keep it. Only y I'm going to remove. So, wherever dy by dx is there, I will be having dv by dx minus 1. So this equation now I can write it as sine square v into dv by dx minus 1 equal to 1. Do you agree with this?
Yes.
Agree with this? Yes. So I can write dv by dx minus 1 is 1 upon sine square v. Right? Now is it possible for me to separate the variable? Tell me. Please respond.
Yes, sir.
Okay, am I right? Now I can write dv upon 1 plus cos x square v equal to dx. Now we can integrate and get our answer. Am I right? Have you understood the idea? Whether it is integrable or not, we'll think about that later. All the v has come with the dv, all x has come with the dx, we can integrate. Did you understand this method? This method is known as what? What is this method known as? Substitution method. Tell me the summary of substitution method. Mandar, what did you understand by substitution method in differential equation?
In substitution method, we get an equation in which we cannot separate the x and y term.
Yeah, the problem that you're facing is we cannot separate.
So we substitute x plus y as v, and then make it differential.
There are only 2 cases in substitution, so easy to understand. One is angle part cannot be separated. Another is power inside the base, something raised to base. Inside the bracket, we cannot separate x and y. These are the 2 types of problem alone we have substitution. Or you have like this, e raised to y by x. Now you can't separate y and x here. In that case also, we put this as v. Okay, so first we cannot separate, so we do substitution. How to decide substitution? Bad angle, bad power, etc. Then after that, how do you do substitution? Mandar, now continue. How do you do substitution method? What is a variable we are removing? How do you come to know which variable to remove? So we substituted, Mandar, are you hearing me? You substituted x plus y by v. Out of this 2 variable, One should go away and one should remain. Which one will go away?
Y.
Y will go away. Why should go away? Why not V?
Dependable
Y
variable.
is a dependent variable. What is the new dependent variable we are bringing in?
V.
V. Is that clear? Okay, let's start with the problem. So I don't think now you need my help to do the problem. I need to give a problem which you can easily integrate. So why did I do not continue with this is it may not be easily integrable. So I did not take that thought about it. I just put a problem and showed you. So let's take a question from your book which you can easily integrate. So write this question. Dy by dx is cos of x plus y. What to note here? Are you writing the note? Here, variable cannot be separated. So the bad angle x plus y is substituted as a new variable. We denote that variable by v. Now remove y from the equation and bring v as the dependent variable. This you don't write in the exam. This is your understanding. Okay. Now let's start solving. Dy by dx is equal to cos of x plus y. You put x plus y as v. Now what I should do after this step? Tell me what I should do after this step. Speak out. Differentiate with respect to which variable?
X.
X. Differentiate with respect to x. When you differentiate, x became 1, y became dy by dx, and v became dv by dx. So in place of dy by dx, you will replace dv by dx minus 1. Okay, so now my equation became, this is a continuation, okay? Therefore, dv by dx minus 1 is cos v. Now you can separate the variable. So dv by dx is 1 plus cos v. So dv upon 1 plus cos v is dx. Now it is a variable separable problem. So now integrate. Now integrate this. When you integrate this, you will be getting integral dv upon 1 plus cos v is integral dx plus c. To integrate 1 plus cos v, what we must do? Anybody?
And by x by 2.
Very good. 2 cos square v by 2 is the fastest method. Any other method to integrate this?
Tan x by
Tan x by 2. Very good. Excellent. The integration. Till now, whatever question I asked you in integration, one or other student has always been given me the answer. Now this is a direct formula of integration. So it is tan v by 2 upon 1 by 2 is equal to x plus c. Now only step is left is remove v. The v is put by us. So tan of x plus y by 2 is equal to x plus c. Now I want to tell you one thing. Actually, in every differential equation, we are supposed to find what is y. Although your textbook is not demanding this, but just for your information, you are actually supposed to make y as a subject. Okay, most probably your textbook is not demanding that. But if at all they ask you, just have in your mind, x plus y by 2 is tan inverse of x plus c. So I can write from y is equal to minus x plus 2 tan inverse x plus c. Actually, this is supposed to be my solution. This is supposed to be my solution. But your textbook is not demanding this, so you may not do it that way. Because we want to find out what is the y, what function will satisfy this equation. I am going to say that this function will satisfy this equation. So this is a solution. Have you got the idea? So you can leave your answer here and you can write here which is a general solution. Most of the international books, if you see, they will make y as a subject wherever it is possible. Okay. Can we move to next problem?
Yes, sir.
Okay, try yourself. I am going to mute after the writing the question. X minus y the whole square into dy by dx equal to a square. Remember, a is a constant. Only x and y are the variables. So we put x minus y as v. Power base has got x and y. There is a power. So base will be put as v. Now to remove dy by dx, differentiate with respect to x. So 1 minus dy by dx is dv by dx. So dy by dx is equal to 1 minus dv by dx. Therefore, v square into 1 minus dv by dx equal to a square. V square minus v square into dv by dx is a square. Now we'll make dv by dx a subject and then only we can decide where to what to transfer. So I can write v square minus a square is v square dv by dx. I try to keep dv by dx a positive. So I'll cross multiply now. Dx is equal to v square upon v square minus a square into dv. Now we need to integrate. Integrating. I hope you got this much correct. Can anybody tell me how to integrate this? Yes, somebody has got
X
minus
minus
a
a.
plus a square.
Yeah, very good. Yes, I got Sridhar has given the answer as a by 2. Correct. Very good, Sridhar. Nice. Yeah. Okay. If you can type that way in the exam, then my problem is solved. Dx is equal to subtract an a square, add an a square. Actually, the degree is equal. Have you noticed that degree is equal? The method is division. If you want, you can divide like this. You can divide like this if you feel, but I'm not going to do that way. But just for your knowledge, I can divide like this. And remainder is a square. The same method I can apply here, like this. Either you can do this method of division, or you can separate like this. Integral dx is equal to, when you separate this become 1, that you can see the quotient, 1 plus a square upon v square minus a square into dv. So quotient plus remainder upon divisor. Quotient is 1, remainder is a square upon divisor. So exactly same thing happens here. So either whenever you notice degree is equal, either you divide. If you can make the denominator same as the numerator by adding or subtracting, then you can do this technique. Now I will separate and integrate. Yes, one more student has given the answer. Okay. So when you integrate this, integral dx is equal to integral 1 dv. Remember, it is dv. A square is a constant. 1 upon v square minus a square into dv plus c. So my answer became x minus is equal to v plus a square log of 1 by 2a. 1 by 2a log of v minus a upon v plus a plus c. Now, what are things we can cancel? X is equal to, in place of b, what you can write? In place of b, I can write x minus y. So x minus y. A and a will get cancelled. So a by 2 log of x minus y minus a, x minus y plus a plus c. 1x got cancelled. Final answer should be y is equal to a by 2 log of x minus y minus a, x minus y plus a. In this case, making y as a subject is almost very difficult. So you have to leave your answer like that. Okay, let me see how many of you got the answer correct. I'll pause for it. Yeah. Now I'm starting with the third question. Third question is, yeah, this is a good one. X plus y divided by dx is equal to sec of x square plus y square. Can you tell me what is the substitution in this problem? What is the substitution in this problem?
X plus y.
Why nobody
X
saw?
plus y square.
Sahil, I can't hear
X
you.
square plus y
X
square.
square plus y square.
Yeah, x square plus y square equal to b. Did you see that its derivative is over here? What is the
Yes.
derivative of x square? 2x.
Yeah.
What is the derivative of y square? 2y divided. That 2 is missing, that's it. So we can, whole thing can be replaced as derivative of b. So you start now. Put x square plus y square equal to b. Now differentiate with respect to x. You can start, continue solving. So this time I'm not making dy by dx subject. This time I'm not making dy by dx subject, because the whole right hand side can be replaced. So that is your observation. Even if you make subject and substitute, still you will get the same answer only, no problem. But this will save a lot of time. So I'll substitute this. Let me call 1, 2, and 3. Substituting 2 and 3 in 1. So half dv by dx is sec v. So dv upon sec v is 2 dx. So integral cos v dv is 2 integral dx. So you got very easily integration done. Sin v is 2x plus c. I should have given you this problem for yourself to do. Sine of x square plus y square is 2x plus c. Is the general solution. I'm going to give you one more question. The question is, cos square of x minus 2y is 1 minus 2 dv by dx. Exactly similar to the previous problem. You can see this is to be substituted and this is its derivative. So please do it yourself. So you will be putting x minus 2y as v. Just differentiate 1 minus 2 dy by dx is dv by dx. So cos square v is dv by dx. So dx is dv upon cos square v. Dx is sec square v dv. Now integrating, dx is integral sec square v dv plus c. Hence answer is x is tan v plus c. So x equal to tan of x minus 2y plus c is the general solution. Very good. Good. Many of you have done perfectly right. Excellent. We'll try one more question. So I have a little more time to do this type of question. So but this question is little, you have to think. 2x minus 2y plus 3. So till now I was doing two types of problem, bad angle and the power. Here I am giving you a problem which you need to recognize by the idea which I am giving you. And they have also asked to find the particular solution if x is 0, y is 1. So particular solution can be asked anywhere. So when the problem is given in this manner, you can see a linear equation here, linear expression. Here also you can see a linear expression. If I make dy by dx as a subject, listen to me. When I make dy by dx as a subject, it will be like this: a1x plus b1y plus c1, and denominator will be a2x plus b2y plus c2. So there are two categories of problem here. One is the slope is same. a1 upon b1, that is minus a1 upon b1, is minus a2 upon b2. In that case, you will be able to get a common factor. Just I'll show you. If the two linear expression have the same, a1 upon b1 and a2 upon b2 are same, look at this: 2x plus 3y plus 1 upon 4x plus 6y plus 1 plus 2, let's say, or plus 3. In that case, you have seen 2 upon 3 is same as 4 upon 6. You have the same slope. In that case, what you have to do is you make the numerator and denominator a common term and put this common term as b. You will be able to separate the variable. If you do so, you can separate the variable. Did you understand the idea? Then quite likely that you will be thinking, if this does not happen, then it does not fall in this category. It falls in some other category which is not there in your syllabus. So I'm not discussing that. You need to only know only those cases where a1 upon b1 and a2 upon b2 are equal. That means that slopes are same. If the slopes are same, then only I can get like this two common term in numerator and denominator. Otherwise, you cannot get. Then you cannot apply this technique. So I'm going to make here dy by dx as a subject. So this goes to other side. 2x minus 2y plus 3 into dx is x minus y plus 1 into dy. So dy by dx will be 2x minus 2y plus 3 upon x minus y plus 1. So dy by dx will be, take a 2 common, x minus y plus 3 upon x minus y plus 1. So we got a common term. So we will put x minus y as b. Now you will proceed in the same way as the previous problems that you have done. Try to do it yourself as much as you can. I am also solving simultaneously. Did you get the idea? So this is a third type of substitution which you have to remember. First two types are easy, bad angle and bad power. Third one is linear upon linear. That time the common term should be taken as v. So 1 minus dy by dx is dv by dx. So in place of dy by dx, I can replace 1 minus dv by dx. Be careful while transferring. This went to this side, dy by dx went to the other side. So now I'll substitute in the left hand side. I'll substitute here. So 1 minus dv by dx is 2v plus 3 upon v plus 1. I hope it's okay. So 1 minus 2v plus 3 upon v plus 1 is dv by dx. I always try to keep dv by dx positive. If the function is negative, it's okay. But try to keep that dv by dx positive. dv by dx. When you take LCM, v plus 1, be careful here. This has got a bracket. minus 2v plus 3 upon v plus 1 into dv by dx is equal to dv by dx. So v minus. So what do you get? Minus 2. Minus of v plus 2 upon v plus 1. Check whether is it okay. So dx is equal to minus v plus 1 upon v plus 2 into dv. Is it all right?
Yes.
How do you integrate this?
+1 -1.
Yeah. Oh, many of students have solved it. Good. Good, Mandar. Okay. +1 -1. Very good. Very good. Very good. Very good. V plus 2 minus 1 upon v plus 2. Now separate this integral. Integral dx minus 1 dv plus 1 upon v plus 2 dv plus c. I don't have space to write. I hope you understand. So I will write the answer here on the top because you don't need question anymore. So your answer is x is equal to minus v plus log of v plus 2 plus c. So x is equal to v is x minus y plus log of x minus y plus 2 plus c. So finally my answer y is equal to minus 2x. This is why I took it other side. Oh, minus y it will become, no? It will become minus y. So 2x minus y. I don't like negative. 2x minus y. This minus and this minus will make it plus. Is log of x minus y plus 2 plus c. Is my answer tallying with the answers you have done?
Yes, sir.
Let me just check the answer. 2x minus y is log of x minus, correct. Now find the particular solution. Find the particular solution. When x is 0, y is 1. 0 minus 1 is log of 0 minus 2 plus 2. Oh. Oh.
So minus 2 minus 1.
X is 0 and
So x minus y plus 2.
yes, that's not 2 here, no?
No, sir.
You know why I said oh? Log of 0 can never come. Log of 0 is not defined. Log 1. So C is minus 1. Therefore, the particular solution is 2x minus y is log of x minus y plus 2 minus 1. This is your answer. Yeah, the bad angle is y by x. So we need to substitute y by x as b. But before that, make dy by dx as a subject. Make dy by dx as a subject. So dy by dx, because we have to remove dy by dx, you know. So that's why we have to make it as a subject. Y sine y by x minus x divided by x sine y by x. So you will put y by x as b. But since I want to replace dy by dx, I'll make y as a subject. So my derivative part will be a little more easier to do that. Now differentiate. So dy by dx. How do you differentiate vx? Which rule should I apply? V and x are multiplying.
Product rule.
V into 1 plus x into dv by dx. So after doing that, this equation will become v plus x into dv by dx is y became vx sine v minus x upon x sine v. Now you can take an x common and cancel with the denominator. V plus x into dv by dx. I'm taking x common. V sine v minus 1 divided by x sine v. Now we will transfer to other side and take LCM. X dv by dx is v sine v minus 1 upon sine v minus v. X dv by dx, v sine v minus 1 minus v sine v upon sine v. They both will get cancelled. So you have minus 1 upon sine v and dv here. So sine v dv is minus dx upon x. Everything is integrable. Such a big equation is reduced to such a small equation. So integrate. Sine v dv is minus integral dx upon x minus cos v minus log x plus c. That becomes your general solution. Now v can be replaced by y by x and log x can be brought to left hand side. So I can write the solution as I'll write some other color. So my general solution is log x minus cos of y by x equal to c. Is it okay? There is a special name for this type of function. Have you all finished writing? Who was the student who gave me the answer? Let me see. Yes, Sridhar gave the answer. Sridhar minus sign ka issue hai na? Yes. Okay, because when you integrate sine v, you get minus cos v. Okay. Now just look at this function. There's something interesting about this function. I am going to call this function in this manner. Numerator is a function of x and y. Denominator is also a function of x and y. And when you replace this function, if you take the numerator function, you will notice a very interesting thing. Replace x by lambda x. Replace y by lambda y. There's a y also, no? So what will happen? Y will come lambda y, sine lambda y, lambda x minus lambda x. You got this lambda will get cancelled. You will get a lambda common, and you will come back to the original function. Thus, such type of function where when I replace x by lambda x and y by lambda y, if I come back to original function with lambda as common, such a function is called homogeneous function. If the lambda's power is 1, it is called homogeneous function of degree 1. Now look at this question. We have done this in pair of lines. Homogeneous function. There also we had homogeneous equation we had. Look at this function. F of x is equal to x square plus y square. If I read xy, yeah, there are two variables here. I hope you understood the meaning of f of xy. F of xy means there are two variables in the function. If I replace x by lambda x, y by lambda y, it becomes lambda x the whole square plus lambda y the whole square. So lambda square will become common and come back to original function. Now the degree of the function, lambda's power is 2. So it is a homogeneous function of degree 2. Okay. Now compare this, what I'm writing next. I am going to write f of xy as x square plus y square plus only x. Now if I replace x by lambda x and y by lambda y, you will get lambda x the whole square, lambda y the whole square, and here you will get only lambda x. So I cannot take, if I take lambda common, it becomes like this. It is not the function x of xy. It is not equal to the function xy. Therefore, this is not homogeneous. This expression is not a non-homogeneous expression. Did you understand the meaning of a homogeneous expression?
Yes.
Just tell me, one of you, what do you mean by homogeneous expression? When can I say a function f of xy is a homogeneous expression?
When we replace it x by lambda x and y by lambda y, we get the same function and multiplied by the factor of lambda.
Lambda raised to n f of xy. And n is the order of the differential or order of the homogeneous function. N will be the order of them. Now look at this. Suppose I have a function like this. And both the functions are homogeneous of same order. Whatever the suppose is order 2, this should be also order 2. Then such a differential equation is called a homogeneous differential equation. So the previous problem that I did was a homogeneous differential equation because the numerator and denominator had the same degree. Now look at this. Dy by dx is equal to x square plus y square divided by x square plus xy. Is it a homogeneous differential equation?
Yes.
Yes, because the degree of each of these terms are equal. If I use the word degree are equal, it is not always true that the function should have degree. In the previous problem, just look at it. That is also a homogeneous function. There we got dy by dx in this manner. Look at this. Y sine y by x minus x upon x sine y by x. This function, numerator and denominator, the lambda gets cancelled. So lambda becomes common here. Lambda becomes common here. Here also get cancelled. So you will have, this is a homogeneous function of degree 1. This is also a homogeneous function of degree 1. Therefore, this is a differential equation. And this differential equation is called homogeneous differential equation. So don't think always algebraic expression should be there on the left hand side. You can have like this also, but such case they get cancelled. So, and there is no need of thinking much. Bad angle you can use here and get the answer. Did you follow that? Now, how do you solve a homogeneous differential equation? I did not tell you that. How do you solve? Method to solve a homogeneous differential equation is put y equal to vx or put y by x as v. Anything you can do. That depending on the situation, whether this is better or this is better, will decide, but both are the same substitution only. And here y have to be removed and v has to come in. Have you followed? Now write down the definition. A differential equation of the form dy by dx is f of xy upon g of xy, where f of xy and g of xy are homogeneous functions of the same degree. Is called, this you put in bracket, a differential equation of this format is called homogeneous differential equation. A function f of xy is called homogeneous function. If f of lambda x lambda y is lambda raised to n f of xy. N is the degree or order of the homogeneous function. Same degree you write, instead of order, degree. Because always power we call it as degree. N is the degree of the function. And we have used the word same degree here. So use the word degree. Now, method to solve a finish writing to how much? Method to solve a homogeneous differential equation. What are method? Put y equal to vx or y by x equal to b. Both means the same only. There's no difference. So we will do next class. We will do problems on this. Again, I think I can do one problem. Okay, it's only 5 minutes more. Solve x square minus y square into dx minus 2xy into dy equal to 0. Very common homogeneous differential equation. Before you start only, you know it is homogeneous. Why? What is the power of x here? 2. What is the power of y here? 2. What is the power of x and y together? 2. Every term in this equation has same degree. Has same degree. This makes you understand which is homogeneous. Therefore, it is a homogeneous differential equation. So you have to every time look. What is the power of x and y? What is the power of x and y? Are they all same? Then it is homogeneous. In that case, make dy by dx as a subject. So I'm teaching how to solve now. Make dy by dx as a subject. So dy by dx is equal to x square minus y square upon 2xy. Hence put y is equal to vx. Therefore, dy by dx is equal to v plus x into dv by dx. So now replace it. V plus x into dv by dx is equal to x square. One sentence you must write here, which is a homogeneous differential equation. This sentence you must write. That's how we came to know put y equal to vx. Otherwise, you can't come to know what you have to do. X square minus v square x square upon 2x into vx. So we can write this as v plus x into dv by dx. Always you will notice when you substitute, x square will get cancelled in every problem. And x square is getting cancelled, that means it's a degree 2. If only x is getting cancelled, degree 1. So x into dv by dx is 1 minus v square upon 2v minus v. Yes, many of you have given. Oh, very good. Okay, I will come to the answer, then we'll talk. Now I will substitute this part. I think I can complete the solution over here. I'll complete the solution this time. reduce a different level. Okay. X into dv by dx is equal to 1 minus v square minus 2v square upon 2v. So x into dv by dx, 1 minus v cube upon 2v, v square, 1 upon 3v square. So I can write now 2v upon 1 minus 3v square dv is dx upon x. Now integrate it. 2v upon 1 minus 3v square dv is integral dx upon x plus log c. I hope you understood why log. So what is the number I should divide and multiply so that the derivative comes here? 6v. So 1 by 3 into 3. I need a minus sign, minus. So my answer will come minus 1 by 3 log of 1 minus 3v square is log x plus c. All right. Now how to adjust it? So I'll do that adjustment last. 1 minus 3 v square is v is y by x. Y square upon x square is log cx. So I can write this as minus 1 by 3 log x square minus 3 y square upon x square is log cx. Is it okay? Yeah. Usually this x gets cancelled. I don't know, this problem is not getting cancelled. Now you can take the 3 on the other side and remove the log. Minus 3 I'll take on the other side. So I'll have to remove this. So I'm doing the continuation of this. So I can write this way. Log of x square minus 3y square upon x square is minus 1 by 3. I'm going to take it as minus 3 log cx. So x square minus 3y square upon x square is cx whole raised to minus 3. So this became x square minus 3y square upon x square is 1 upon c cube x cube. So I can write x into x square minus 3y square is capital C, where C is 1 by c cube. This is my general solution. Correct. I hope you understood this. This homogeneous equation is always 4 marks question. So it will be lengthier than the usual differential equation. So, and it's not very difficult. It's easy to learn this.